There's a quiet crisis brewing in the professional world right now. You might not see it yet, but you can feel it. For decades, the roadmap to success was crystal clear. We were given a simple instruction: pick a lane, stay in it, dig as deep as you possibly can. We were told over and over that specialization was the only key to mastery. If you wanted to win, you had to be the expert in the room. But today, the ground is shifting beneath our feet. As artificial intelligence models begin to replicate deep technical expertise with terrifying speed, the old rules of the game are dissolving. Ask yourself this: what if the very strategy that defined success in the 20th century, hyper-specialization, is actually the trap that will make you obsolete in the 21st? History's most creative minds suggest there is a different path, a better path. Take Leonardo da Vinci. He is the archetype of the Renaissance man. But here is the secret. Da Vinci didn't achieve greatness by narrowing his focus. He achieved it by combining a deep focus with an insatiable, wide-ranging curiosity. He didn't just study painting. He studied anatomy, engineering, architecture, biology. Today, we call this polymathy. Now, don't let that word scare you. It isn't merely a rare talent gifted to a lucky few geniuses. Neuroscience now confirms that this is a learnable cognitive strategy. It is a way of thinking that you can build. And more importantly, it is the single most effective skill that puts you distinctly ahead of artificial intelligence. Part 1. The hidden cost of specialization. Let's look at why the old way is failing. Modern education and corporate structures are essentially factories designed to produce specialists. We are trained to possess deep expertise within a single, narrow domain. Now, specialization has its merits. It builds efficiency. It creates technical proficiency. But it carries a massive hidden cost that almost no one discusses. It shrinks your neural network your brain uses to create ideas. You see, creativity doesn't emerge from the accumulation of information within a silo. It emerges from the connection of ideas across different domains. When you spend your entire career living in one mental neighborhood, your thoughts inevitably begin to look familiar. You start solving problems using the exact same tools as everyone else in your field. This is why innovation often feels stagnant in highly specialized industries. Everyone is thinking the same thoughts. As Michael Gelb highlights in his analysis of Da Vinci, cultivating connections across unrelated fields is exactly what allows your ideas to become original, unexpected, and disruptive. If your input is narrow, your output will be predictable. And in an economy driven by AI, remember this equation: predictable is synonymous with replaceable. Part 2. Redefining polymathy. Let's clear up a misconception. People often think being a polymath means being a jack of all trades, master of none. They confuse it with multitasking or shallow learning or just collecting random hobbies like stamps. That is not what we're talking about. True polymathy is structured cross-domain learning. It is the practice of going deep into multiple distinct fields and allowing your brain to draw bridges between them. It is not about distraction. It is about synthesis. As David Epstein points out in his groundbreaking book, Range, exploring diverse experiences doesn't dilute your expertise. It dramatically boosts your creative intelligence. Think back to Da Vinci. Consider his study of anatomy. He didn't dissect bodies because he wanted to be a doctor. He wasn't trying to switch careers. He did it because he wanted to understand the mechanics of the human form, the tension of muscles, the structure of bone, so that he could paint life rather than just static figures. He used the logic of biology to solve the problems of art. This is the essence of the Da Vinci Method, using the lens of one domain to bring absolute clarity to another. Part 3. The neuroscience of connection. Why does this work? It isn't just philosophical, it is biological. Neuroscience offers 3 compelling reasons why cross-domain learning upgrades your brain's hardware. First is neural network expansion. Your brain operates through networks, not isolated modules. When you learn a new discipline, you aren't just filing away facts, you're physically activating distant neural circuits. True creativity arises from the interaction between two specific brain networks: the default mode network, which is responsible for daydreaming and imagination, and the executive control network, which handles logic and execution. Polymathy forces crosstalk between these regions. You're literally building a super dense, faster superhighway in your brain. Second is analogical thinking. Cognitive science shows that elite problem solvers rely on analogies, not just linear logic. A specialist asks, what is the standard solution in my field? A polymath asks, where have I seen this structure before in a completely different world? This is the engine of breakthroughs. When you have a wide range of knowledge, you have a larger database of analogies. You can borrow a structural solution from music composition to solve a complex coding problem. Third is cognitive flexibility. In a rapidly changing world, the ability to unlearn and relearn is more valuable than static knowledge. Polymathy trains your brain to be fluid, making you adaptable to disruptions, including those caused by AI. Part 4. The pattern of innovators. When you look at history, the pattern is undeniable. Breakthroughs happen between disciplines, not inside them. Look at Steve Jobs. This is perhaps the most famous modern example. He didn't just study technology, he studied calligraphy. He understood the aesthetic sensibility of spacing, typography, and design. He combined that artistic sensibility with computer engineering. That combination is what created the Macintosh. Without that cross-domain connection, the personal computer might have remained a clunky, ugly machine. Look at Elon Musk. He blends physics, engineering, economics, and manufacturing. His first principles thinking is essentially a way of breaking down problems across these fields to rebuild them more efficiently. Part 5. The Da Vinci Method, a practical framework. So, how do you apply this? You don't need to be a genius, you just need a framework. Here is the 4-step method to create creative friction. Step 1. Choose your anchor field. Identify your core expertise. This is your home base, the skill you're paid for. Maybe it's software engineering, or accounting, or graphic design. Step 2. Add a distant field. This is the critical step. Do not choose a field that is next door to your anchor. If you're in marketing, don't choose sales. That's too close. You need distance. Think technology plus psychology. Think business strategy plus ancient philosophy. Think architecture plus music theory. The goal is to force your brain to bridge a wide gap. Step 3. Extract transferable patterns. Once you start learning that distant field, stop looking for facts. Start looking for patterns. Ask yourself, how does this field solve problems? What metaphors does it use? What are the fundamental models here? For example, if you study biology, look at how evolution iterates designs. Can you apply the concept of natural selection to your project management workflow? Step 4. Force integration. This is where intelligence compounds. Actively force the two fields together. Try to explain a concept from your anchor field using the vocabulary of your distant field. If you're a coder studying storytelling, try to explain your code architecture as a narrative arc. This forces you to understand your own work at a much deeper conceptual level. Part 6. Building the habit. You don't need to go back to university to do this. You need curiosity and consistency. Adopt the 15-minute rule. Spend just 15 minutes a day exploring a field completely different from your main expertise. Read an article on astrophysics, watch a video on color theory, listen to a podcast on history. Feed your brain fresh ingredients. And keep a connection journal. When you notice a similarity between how a jazz musician improvises and how a team negotiates a contract, write it down. This trains your mind to scan for patterns automatically. Final thoughts. We are entering an era where AI will always possess more knowledge than you. It can access the sum of human data in milliseconds. It can pass the bar exam. It can pass the medical licensing exam. But AI struggles with context. It struggles with lived analogies and the embodied understanding that comes from struggling through different disciplines. AI can generate data, but it cannot easily replicate the spark of intuition that jumps from studying the flow of water to designing a better traffic system. In the AI era, being a deep repository of facts is no longer a competitive advantage. The advantage belongs to the connector. Leonardo da Vinci didn't ask, "What specific thing should I focus on?" He asked, "What else might be connected to this?" If you want to future-proof your career and grow your creative intelligence, stop worrying about digging your hole deeper. Start looking around. Go wider with intention. The next great breakthrough is waiting for you, but it isn't in your lane. It's in the space between.